What we want to look at here is graphing systems of inequalities. We've solved systems of equations, both linear and quadratic, and now we're going to look at inequalities. And we've talked about inequalities before, and we know that we need to use dashed lines or solid lines, and we need to shade above or below the graph. And really what we're doing now is we're combining what we learned about inequalities and now what we're learning about systems. And so we're going to be graphing these systems, and when we graph these systems, we're really just looking for where those graphs overlap each other. So we'll go ahead and take a look at this example. We want to solve 3x plus y is less than or equal to 4 and x plus 3y is less than negative 6. And so what we need to do first of all for each of them is we want to put them in slope-intercept form so we can easily graph them. So we'll take 3x plus y is less than or equal to 4, and we'll subtract 3x from both sides. And that gives us y is less than or equal to negative 3x plus 4. And then taking the next equation, x plus 3y is less than negative 6. We'll subtract x from both sides. That gives us 3y is less than negative x minus 6, and divide both sides by 3, which is really dividing each term by 3. And we can say y is less than negative, and we can think of this instead of divided by 3, this is negative 1/3 x minus 2. And now what we want to do is graph this. Let's go back up to our red. We have a y-intercept of 4. So let's put a y-intercept of 4 on here, and a slope of negative 3, which we can think of as negative 3 over 1, so we'll go down 3 over 1. Down 3 over 1. Down 3 over 1. When we graph this, we want to use a solid line because it's got the or equal to. So I have the line right here. We'll graph that, and we have negative 3x plus 4, and then I want to shade. So here's our shading. It's a less than, so we want to shade below, and that's what that would look like. And then we want to graph our green. So let's graph our green equation here. This is y is less than negative 1/3 x minus 2. So we'll start at negative 2. On the y-axis, we have a slope of negative 1/3. So down 1, right 3. Down 1, right 3. Or from here, we could have gone up 1 and left 3. We can do that a couple times, up 1, left 3. And that gives us a good idea where that graph should be, and we'll go ahead and graph that. It's a less than, it does not have the or equal to sign, so this is going to be a dashed graph. And so there's that, and then it's a less than, so we're going to shade below the graph. And for our answer, our answer is everywhere where these graphs overlap, and so we want to graph where they overlap, so our solution is going to be down here where they're overlapping all in this section. And so what this means is that all these points in this shaded section will make both of these inequalities true. And so we can pick any point in there. Now remember, the points on this dashed line will not work, but the points on the solid line will work. So that is the solution to this inequality. Our next one is similar. We will take our first equation. The green one here is already solved, so we'll take our other one. And we have 3x minus y is less than negative 3. We'll go ahead and subtract 3x from both sides. That gives us negative y. Negative y is less than negative 3x minus 3. We want to get a positive here, so we're going to divide by -1. When we divide by a negative, we have to switch the direction of the sign, so we have y is greater than 3x, and this is a negative divided by a negative, so 3x plus 3. And now we can graph each of these. Let's start with the one we just did. So this has a y-intercept of 3. And we want to go up 3 over 1. That was just 2. We need to go up 3 over 1. That would put us here, and down 3, left 1. We can do that a couple times, and that will give us the graph of that line. This is a less than. It does not have the or equal to. So our graph is going to look like this. And this is a greater than, so we want to shade above this graph. And so here's our shading. We're going to shade above there. And then let's take our green inequality here and graph that. So we know this goes through -1 on the y-axis. Once again, we want to have a slope of 3, so up 3 over 1. Up 3 over 1. We can graph that. Here's the graph of that line. Again, it's dashed because it does not have the or equal to. And this is a less than, so we're going to shade below that. And we see here that this is going to be no solution because our graphs don't intersect anywhere. So we know that this one here, and we can actually write this one out, we know that this is no solution. So neither those inequalities didn't overlap anywhere. Our last one we're going to look at is parabolas. And so we have to remember how to graph parabolas. Now these ones are already in work form, so they shouldn't be too hard to work with. We'll start with our red one. This is just y is greater than or equal to x squared. Well, we know x squared has a vertex here. If we think about a few of our points or make a table to find a few of our points, we would find these points. And again, we could do that by plugging in some values if necessary. So we could have x and y. Plug in 0, you get 0. Plug in 1, you get 1. Plug in 2, you get 4. And since there's an axis of symmetry here, we have the same points on the other side. So that's the graph of that. And we can put that on our graph about right there. It's a little off for some reason. So it should go through these different points up here. And then what we're going to do is this green one. We want to graph this. And this one is a parabola again. It's going to be moved up 1 because it has a 1 here, so we're going to have our vertex here. This is going to make it less steep. And so we can put a couple points in there. I'm going to use even numbers. So let's do 0. We know actually if we put 0 in, we'll get 1 already, but let's put 2 in. 2 squared is 4, but half of that is 2, plus 1 is 3. So we get the point 2, 3, which means -2, -3 is also in here. And then we have this graph, which we can fit in here. And what I should have done before, we have the red graph is a greater than, so we would shade above the red. And then we would shade below the green graph, so that would be everything out here. And we're looking for where those two graphs overlap or intersect, and that is going to be this small section. Kind of looks like a smiley face in here. That's going to be in here. This is where the two graphs intersect. And so that would be the solution. So all these points in here make both of these inequalities true. And that's solving systems of inequalities. We want to graph each of the inequalities and find out where they overlap.